Alright, I wrote the formula here. It looks very complex, but it's actually not so difficult, and that's why we will do an example to show you how it really works. Now this X here, this is basically the intensity. It's the number in your matrix between 0 and 255. Yeah? So this is the formula for a two-dimensional image. Yeah? And in order to show you how it works, I've defined a signal here, an arbitrary sequence X of N2 and N1. And here is the impulse response H of N1 and N2. Yeah? And our goal is, of course, to calculate Y. And how we're going to calculate Y is by taking the convolution between X and H. Yeah? So these are two very simple signals. Yeah? Here you have the details on the outcome, but not so important. Just look at the picture and see what happens. So the first step we need to do is we need X in function of K1 and K2. So this is actually very simple. We just change N2 to K2 and change N1 to K1. Yeah? So this is K1, this is K2. And the first step in our convolution operation. So we had N1 and 2, we swap to K1, K2. Now in step 2, we decide to keep the arbitrary sequence as is. So we keep now, so it's X, K1, K2 as is. Yeah. But in terms of the impulse response, we're gonna define what H minus K1 minus K2 is. Forget the N, for example, for the time being. Consider it 0. So we go from N K1 to K2. We go to H of minus K1 minus K2. Yeah. So basically what you're gonna do with H is you're gonna flip it. This 4 will become here, yeah, because this is +1 +1. Now it becomes -1 -1. So this 4 will be here. Yeah, the 1 in the middle doesn't move. Yeah, and here we have the 2. And here we have the 3. Yeah. So this is still H1. Sorry. This is now K1, K2. Still there. And now in step 3, what we're gonna do is we're gonna place this function here at different offset values for N1 and N2 so that we get the calculation of this. Yeah. So basically what's gonna happen is we're gonna keep the signal X1, XK1, K2 as is, and the flipped signal of H, we basically gonna move from the left to the right, and at each point we calculate this convolution. Yeah. For example, situation 1 is where you have, the X we keep is 2. Let's start 2, 3, 5, and 4. All right. Now, when there is no overlap, this will always be 0. Yeah. It will only be non-zero when there is overlap. So basically what you can see is that basically what convolution does is, you start from the left with your signal, your impulse response signal. You keep this one as is. You start from the left and you calculate the convolution as you actually slide over the other signal. When there's no overlap, convolution 0. So I would say on the left side, the situation we will have is that this will be 1, yeah, this is this one, this will be 2, this will be 3, and this will be 4. Yeah, so for this situation you have y 0, 0 equals x0, 0 times h0, 0 plus, no, it's just like this, right? Because there's only overlap here. So this is x0, 0 is 4 and this is 1. So y0, 0 equals 4. Okay? When we would have had it more to the left, convolution is 0, does not contribute. So the next situation is where we have again our signal x that we don't touch. 2, 3, 5, 4. And we move the red ones just 1 unit to the right. So that means that this will now be 2, this will now be 4, this will now be 1, and this will be 3. Not so difficult to calculate because there's only overlap here and here. So y0, 1 equals 8 plus 2 times 4 plus 5 times 1 is 13. Alright? And now the last situation, again we keep sequence as is, 2, 3, 5, 4, and we move the red one another 1 unit to the right. So basically what you're gonna have is you're gonna have 2 here, 4 here, yeah, and then 1 here and 3 here. Convolution is easy to calculate because it's gonna be 5 times 2. So y20 is going to be 10. Yeah. So and that's it. This is of course a discrete case, but the way you have to look at it is that you have a certain signal, like your sequence in the beginning is basically could be this. Now it's 0, goes to 1, like this. This could be your X signal. And what you do with your impulse response is also a sort of step. Yeah. So you start basically in the true convolution. You start from minus infinity. Yeah. So you start from here and you move this to the right. When there is no overlap, this will be 0. Yeah, so you move it. At some point you will start to have overlap. Yeah, you will have overlap until you move it here when there is no more overlap. So here as well convolution will be 0. And here your convolution signal will actually increase the more overlap there is. Yeah. So it's visually a little bit easier to grasp than when we just look at points. Yeah. So this is actually the idea I want you to grasp, is that convolution basically means that you have one signal which you keep at it, and then you move a second signal that we call a filter from -infinity to +infinity. Yeah? And basically this is gonna create a third signal. Yeah?